So, last time we did stuff. Now it's time to do more stuff. This is basically how Universe Sandbox and its works. You just do stuff and it responds to it very dramatically. So today, what we're going to do is we're going to do some pretty insane stuff, right? We we really need to one up ourselves from the last time. Means that we have a habitable zone right over here. Now, if you guys remember correctly, in the last time we did a pretty nifty thing. We had planet binary and shit. So today we're going to do that, but double. As you can see right here, we have two stars orbiting each other. We can go quite fast actually, this is fun. And they're just zooming around, just not doing much. But if you zoom the orbits, right here, orbits, you can see they don't technically orbit each other because actually they're orbiting an invisible body center. But yeah, shut up. I like space, but I don't like when people overcorrect me on space. So we're going to do today is we're going to focus on the planets. Mainly, last time we got a beefy planet. We got a very beefy planet. And right over here, we're going to put it like on the edge. Right there. Nice. What's your name? Unex. Unex. What's your mass? You're not very massive, but we'll change that. Not manually though, because that would be boring. We're going to throw stuff at our planet, our little planet friend. As you can see, he's kinda in the red because technically, first we need to see if he'll survive. Yeah. Oh, his orbit's all over the place. I don't think he will survive. Let's speed up and see. Yeah. He won't. As you can see, usually bari centers like these are really unstable. They're not very good for housing planets. They're more good to be nifty. So carrots, right? We'll pause. Let into orbit. Let's see if that changes anything. And let a second one into orbit more or less in the same space. Let's see how that goes. Okay. Let's see if this works. It may work better than the other one. Yeah, it's not gonna work. Alright, new test. New test. You gotta figure out a way to do a video. So I think what we want to do is we want to have a really massive star and a not so massive star that's still technically a star. So Alpha Centauri A, right here. Proxima Centauri, how big are you? Not very much. What are you? You're 192. You're less than a sun. You're way less than a sun. So yeah, you're kind of half the mass of the sun. Ooh, but you're really small. Okay. Led into a balanced motion binary. We'll put it like, I don't know, I feel like, right here. That worked, right? Come on, that has to work. Habitable zones. Oh boy, this is like, yeah, this star right here, it barely has a habitable zone. Yeah, it's like really small. Okay, without further ado, let's first test if this can keep stable. I think it will, considering that one is not that big. Okay, so we unpause and speed up time a bit. A couple days a second, that's good. Months a second. And it seems like Alpha Centauri is barely moving at all. Which is good for us, because the less Alpha Centauri moves, the more stable this whole relationship will be. Making a binary universe sandbox is a lot like making a science fiction couple. Oh, it's moving alright. Let's activate trails. Oh yeah, it's moving. It wasn't moving because we had it focused. Ooh, that's gonna be a problem. But yeah, making a binary universe sandbox felt like making a relationship couple in a fictional story. You can fuck around and find out, but oh boy, it's not gonna usually end super well. 51 peg B. Right? 51 peg B. Think you're gonna go right here. There you go. 51 peg B is a speedy boy. And then Jupiter. Right over here, pal. Can go there. Jupiter is like my favorite planet to have around solar systems, because he always messes stuff up. He has like such a big gravitational pull compared to other planets that every time anything happens, it's his fault. Let's just see if we added. Yep, we added into orbit. If we add into like balanced motion binaries, what usually happens is it will stop the star that's orbiting, right? And then these two stars will collide, which is not what we want. We want a fun little time. And I think we can start adding. Yeah, I think we can start like messing around more with stuff. Like right here, we'll have the Uranus and Alpha Centauri's orbit align. Not gonna help a lot, but here, Venus. We're also gonna have like touch tips. Right there. Now I want to see what happens. And so we slow down a bit. Not that much, come on. Okay, there we go. More or less like that. And you can see Uranus and Venus, they're kind of lagging behind. If you check their orbits, I think they'll be very oscillating. Yep. Uranus's orbit is the most oscillating one. It actually switched orbits, and it's starting to orbit this one. And as you can see, this star right here is actually orbiting Jupiter more than it's orbiting Alpha Centauri. So we have a double binary, which is working by sheer will, I guess. As you can see, Uranus's orbit is kind of freakish, but I think will work, because if we check back to trails, as you can see, still working. So that's good for us. So if we speed up time a bit more, what happens? 51 pack B, still orbiting Alpha Centauri. Venus is now orbiting Alpha Centauri, and Uranus is kind of just being chucked around, I guess. Is Uranus even still orbiting? But yeah, not that sure Uranus is gonna make a comeback anytime soon. We'll check, maybe by some strange miracle. Let's check. Eventually, everything should either come back. Oh yeah, we're in years per second. Yeah, Uranus is not coming back. So you had to be yeeted. Venus though, still pretty strong. How big is our boy Venus now? How is it? Yeah, he's still kind of the same. His temperature is falling, but he has such a big atmosphere. Every time he cruises by a star, it's kind of no-brainer. Yeah, as you can see, his temperature like is falling, but now that he has a clutch, it's gonna start changing less drastically. Oh boy, did he just get ejected? Oh no, it's still a bit weird. If we check around his orbit, I think, oh yeah, Venus is a goner, sadly. Okay, that leaves us back with the originals. 51 peg B and Jupiter. We're 19 years per second. This is a big change. Okay, so we'll have Giselle right over here. We'll have it cruise by the center. have this planet right here. Kepler, a bit far away from Jupiter. Now if we slow down time again, because again, it's like simulations, so we need to be wary. Okay, then we'll go back to home because I want to focus on Alpha Centauri since it's dictating most of the parts. And as you can see, most of the stuff seems pretty stable up to now, which is an oddity in binaries in Universe Sandbox. If you ever tried to make a binary system like this, you know how volatile they are to change. These little things, they can fling around planets like no tomorrow, and sometimes you cannot do anything about it. So as you can see, Giselle's orbit is the most unstable one, with Kepler surprisingly being very stable considering it's orbiting the lesser star. Usually what happens is the lesser star is harder to keep planets because they keep getting pushed towards, bigger stars. But this time, we're having balance. No stars are trying to steal others' planets, at least, not after Uranus and Venus got ejected out. I think what happens is they saw what happened, they saw that both planets got snapped out. They were like, ooh, okay, if we keep fucking up, it's eventually gonna be us. And they decided, yep, we're gonna share. So as you can see, Kepler, 51 Peg B, and Giselle, I don't know if I'm pronouncing that wrong or right, I don't know, call it Giselle, they're orbiting peacefully. They're having union, they're having harmony. It's a little harmonious system. And at 11 months, oscillating between 11 months and 1 year, we are having a blast. However, it's gonna go forever. Because as you know, in Universe Sandbox, we need chaos. It's a part of what makes everything so fun. So what if we take, how big is the star? Give me the info. Oh, your free sun. So if you launch it, oh, you're a big star. I don't know if you're big or if you're bright. I think you're just bright. So if we check, oh yeah, Stevenson. Stevenson's a big boy. Yeah, Stevenson's a big boy. I don't like the glow effect they do, but marriage. Get back at again. Polaris. You're good. Okay. So I zoom out. If we're way over in the corner. Oh yeah, that's a big star. Now if we check, what happened here? Oh yeah, we're just zoomed out way too much. So as you can see, Polaris AB, for some reason, where is it? Okay, oh okay, it's way over far over here. Okay, I may have zoomed out way too much. But if we speed time up, we should start seeing an increase in velocity, right? Okay, so it's really slow. Yeah, okay, switch this off. It's really slow, so we need to do some tinkering. We'll multiply its velocity by 10. Right, where is it? Speed. There you go. Speed. By 10. So it's oh yeah, no, halving it again. There you go. Way better. Polaris AB. Should it disturb the orbit of any of these stars? We'll see. So far nothing. So far everything's peaceful. However, Polaris AB is distancing too much, so we may need to halt it. Halving its speed again. Where is it? Rotation? Yeah, speed. We'll halven it again. So we did both. Yeah, we did all that for nothing. But it's only because I thought it was closer. Threw it too far away. But I think it will have an impact sooner or later, right? If we check right here. Oh, Alpha Centauri. Okay, this is interesting. Alpha Centauri is orbiting the lesser star. I don't know what prompted the change. But again, it seems like the two of them are still having a blast. Yeah, it still like kind of keeps the balance together. I don't know why that happened. I don't know if it's something I did. But Polaris, you orbiting anything? No, you're not. Sadly, Polaris, I think Polaris will just like have a sad little existence. Since it's not doing much, it's just kind of cruising by, which is sad in Universe Sandbox because usually these stars have a profound impact. Okay, if we click it, we should see where it's heading, right? Ooh, yeah, it's not gonna do much. I think we'll need to switch our tactics. Okay, so it was right here. Okay. Ooh, yeah, we can see they were spiraling up. So it was having a slight effect, but not that kind of effect I want. So we need a little star, crab pulsar. At the Carinari. Ooh, you're big. Mass 55. Ooh, yeah. We'll go for the crab pulsar. We'll launch it up right over here. There's a pulsar, so it should be very chaotic. Yeah, there you go. And as you can see, it's going fast. It's disturbing the orbits. Oh yeah. Oh yeah, who got flamed out? Kepler. Goodbye. Now the crab pulsar is fucking shit up. Very much so. So we leave it to trails. Oh god. Okay. Alpha Centauri A is down for the count. I think everything's down for the count. Yep, that concludes the experiment. Goodbye.